Let's go ahead and get started. I'm sure some folks will be coming in, but let's make use of the full time that we have. So good morning, everyone who's joined. I'm Doug Davenport, CEO of Prospect Silicon Valley. I'll be introducing other members of our panel here shortly, but we're here to talk about two exciting pilots that we're involved with on managing energy in multifamily housing. I think you'll find this to be a really exciting approach to managing power capacity and resilience and loads within apartment buildings. And we're looking forward to the discussion that ensues. So with that, let's go ahead and get started. Next slide there, Maddie. There we go. So I want to start with a little bit of context before we introduce our panelists. So these, rough numbers in California, there's about 13.5 million housing units in the state, at least according to the last count that we have. Of that 13.5 million, about 4 million are multifamily housing units, and half of those are low to moderate income. So enormous population. In that 4 million multifamily housing units, we estimate, and Sean Armstrong is going to be showing some numbers on this, somewhere around 2.5 to 3 million of those units could have 60 amp panels or less. It's an enormous number of apartments with relatively small service. This is a really important consideration for electrification of these buildings. Let's go to the next slide and we'll show you what we're thinking. That 2.5 million to 3 million units represents 2.5 million to 3 million panel replacements and service upgrades and additional load onto a grid that may already be stressed. That's a very big problem. The upgrades alone could be considered about a $45 billion problem, not including everything that happens beyond the property. So this is an enormous problem that we see. And a few of us got together and said, we see trends in the technology, we see trends in the market. We think that there might be a different approach. We're very fortunate that we're able to pilot a technology approach that addresses this very problem. We're very grateful that we can have that opportunity. We're going to be discussing two different pilots that we're working together on. If we go to the next slide. Our whole hope is to redirect some of that investment that would be happening in those panel upgrades and service upgrades into something productive, carbon-free, resilient housing instead of additional capacity. And so we want to look at that problem carefully. Let's go to the next slide. So talking today in a group that we're very lucky to be working with. Just going from left to right on the screen, David Kaneda, principal at Ideas Consulting. Ronshan Yin, a longtime partner of ours and a technology researcher at the Lawrence Berkeley National Lab. Kimberly Beltran, a technical programs manager at Sonoma Clean Power and partner to us on one of the two pilots that we're discussing. Sean Armstrong, managing principal at Redwood Energy and our key partner up in the Redwoods on pilots that we're doing in that region. And then, of course, last but certainly not least, Ilse Villacorta, project manager and senior project lead for Prospect Silicon Valley. So this team is going to be taking over from here and talking about the background of this project, the way we're approaching this project, and we're looking forward to a rich discussion. With that, Ilse?
Thank you so much, Doug. And I'm going to be a little discombobulated head today. Apparently my video didn't want to participate. But today our talk is going to be focused on what are the barriers of power capacity and load management in multifamily retrofits. David, Sean, and Kimberly will be speaking to both capacity constraints and grid constraints. And then next, David will be speaking with Bronchen Yin about the innovation that we're presenting to you today regarding smart panels, plug-in batteries, and the controls that we're developing. I will be speaking a little bit about the actual CEC project goals, the timelines we have set out, and some details about our technology demonstrations. And then Doug's going to help us lead us into discussion and Q&A, but talking about how you can stay engaged with these projects, what you can hope to learn from in the future, and then we'll be moving into some Q&A and some closing. So next slide. So the challenge and why we're here today and why why we're talking to you about some CEC grant projects. The challenge is, how do we manage electrical capacity and demand when electrifying existing multifamily housing? And with that challenge setting, I'll move into our first topic, our first problem that we're trying to tackle. What is the capacity problem? And with that, Sean, I'll let you take over.
Thanks, Jose. Okay, next slide, please. So it was fun, got to buy all of the code books going back into the 1930s to make this little timeline of like how and what happened when. So what I've learned is that from 1947 to 1959, the National Electrical Code required 60 amp services to houses, great for them, but not apartments. There's never been a requirement for the minimum to apartments and still isn't. It's always done by an engineer and that's it. 1962, houses once again got a 100 amp service guarantee for all houses, no minimum to apartments. 2016 in California exclusively, we got 200 amp services. And in 2016, 200 amp services. And in 2022, apartments for the first time were required to have pre-wiring for electrification, which functionally increased the size of their panel, but there is still no minimum size for an apartment panel. Next slide. All right, so let's just talking about multifamily, drilling down. So the buildings with 2 to 4 units and 5 and above units, you can see there, like low, moderate income households is the first column. Lots of folks in California. There's lots of folks also that are not low, moderate income households. And you get them all combined together. You have a little bit more than 4 million households living in apartments. Right now, today, a little bit more than 30% of the housing that's built in California is apartments, and roughly half of that is low, moderate incomes. So, next slide, please. This is fun to look at it. It's kind of visually over time to get a sense of, so where does the problem physically exist? So service panel capacity in California multifamily housing, cool little study. You can see at the bottom, Fournier, Cud, Smithies, those folks, 2024, nice and current. So let's just look together at the graphic there. At the bottom of it in gray, that's the share of the category that was built in those years. So you can see 28% of California housing is built before 1930, more than 1 in 4 units. That's a lot, right? It's a quiet time in the 30s, Depression, 1940s, just sort of getting by with World War II. But at the end of it, they're building a lot of housing and lots in the 1950s and 60s with baby boom, post World War II. And it's diminished ever since. You can see in 2010, it's a very small amount of housing being built relative to what was historical trends for apartments. That means that our homes are going to be significantly weighted towards the 1960s and 1930s designs. 87%, in fact, was built before 1980. So let's just look at the graphs going up to 1980. 1930s, you can see that under 60 amps, that's about 99%, and 84% is 60 amp panels. 60 amp panels in orange. And then up above that, there's larger panel services that are built. We'll ignore those. Let's just look at the orange. That's the 60 amps. You can see it's 84% before 1930s, 62% in the 30s, 51% in the 40s, 56% in the 50s, 66% in the 1960s, 60% in the 1970s. It's essentially always the majority of the housing until the 1980s, which is 13% of the housing is built without that being an issue, where you start seeing in red the 90 amp panels, and those are enough. You can do a whole apartment essentially all electric without any significant issues with 90 amps or more. But 60 amps is a trick. So, yeah, the bullets on the left-hand side just make the same point that I'm making here by looking at that graphic. So we have a significant problem. Most of our housing was built with 60 amps in apartments. Most of it, like the majority, more than 50%. Next slide. So
So I think this is me,
that's for
right?
you. Go for it.
Yeah. Okay. So I think, Sean's talking about lots and lots of 60 amp panels. So kind of what are the solutions that are available now? The typical solution is you're electrifying an existing housing unit with a 60 amp panel as you upgrade the service and upgrade the panel, right? And we're seeing lots of that trying to happen, but imagine you have a apartment campus, and every service is a utility service going to each unit. So you're talking hundreds of upgrades if you're trying to use that solution to solve your problem. Um, and so people are looking for other solutions. So, one solution is to take, as you're adding electric load, set it up so you can only run one of two things at a time. So, for example, um, there are things called circuit splitters that it's like A or B. So, what's an example? You can run your electric cooktop or charge your car. Um, but not both at the same time. Sean brought up a great one. There's heat pump washer dryer systems that are made. So since it's a single unit that does washing and drying, you can't do both washing and drying at the same time. So that limits the amps that you're using. Um, the other thing is there's starting to be this new class of equipment that is like electric cooktops, but they're only 120 volts rather than the what you would normally see if it was electric 240 volts. And there's also starting to be heat pump water heaters that are also only 120 volts, so use less amps of electricity and help you to avoid upgrading your home. Same thing with heat pumps. Next slide. And then there's the old strategies of, put a heat pump water heater instead to replace an electric resistance water heater. Not so common in California, but in other parts of the US. That's a solution that could reduce your amps. Replace halogen and fluorescent light fixtures with LED. Envelope upgrades on a residence. Um, using night flushing strategies to cool your house down at night. Using aux sensors, using electronic equipment like laptops that'll shut down automatically when they're not being used. Um, those are all potential upgrades in a housing unit, and some of these are not so easy to do if you're in an apartment because you don't own the place. Next slide. So there's also an impact on the grid that we need to be thinking about. Next slide. And so um, it- there's two things that kind of get used kind of interchangeably, but they're not really interchangeable. One is the actual demand in amps or in kW that a building has or a site has, and the other is the amount of energy that it used. So the one is how high that curve is, how tall it is. That's the demand. And usually we're talking in amps, but sometimes we're talking in kW. It's more or less the same thing. Um, uh, Advance one slide, Madeline. Yeah, so you can see it there. So this is a graph that I created that shows, like a typical building, what it might use. So, 90 amps maximum demand. But if you could flatten out the demand, and still use the same amount of energy, then that graph down below that says 46 amps maximum demand is using the same amount of energy, but the demand is roughly half of the graph up above. Next slide.
One more,
Yeah.
yep.
So Kimberly's going to take over and talk about what are the issues here.
Right. Thank you, David and Sean, for kind of setting the stage. So one of the things that Sonoma Clean Power looked at when we went into this partnership with ProspectSV and Ideas Consulting is looking at ways that we could really address our disadvantaged community, which we define under Cal Enviro Screen SB 535. We know this particular area in our service territory to have faced kind of four major drivers that's impacting the distribution system. The first is demand growth. This is a development part of our territory. We have a Boys and Girls Club and lots of additional housing. We've got lots of commercial going in. It has historically been underdeveloped. And over the last 10 to 20 years, we see quite an influx of not only new multifamily housing, but other commercial properties as well. This particular community has circuit limitations that are persisting. So several feeders operating near and around this neighborhood are at or beyond planned capacity. So this challenges our ability to accommodate service requests at large without significant infrastructure upgrades and cost associated. So additionally, service upgrades. This is an affordable housing project that we're specifically looking at. They're often straddled with escalation in retrofit projects. They're looking to electrify, but they've got service upgrade costs, delays by the utility to interconnect when they do make those changes. Properties really face expensive distribution size upgrades with long lead times and increasing the service size. And beyond all of this particular community has aging infrastructure that has been low in the queue to have those really critical upgrades. So the local distribution system is really not designed for today's load densities or behind the meter technologies. Things like electric vehicle chargers, rooftop solar and storage are lagging and trailing because of the impact to those services. Next slide. So this particular, I wanted to highlight demand response barriers in disadvantaged communities. We have a high tenant load of the occupants in this particular service territory in this DAC. Barriers, having buy-in from building owners. So you're renting a space, there are things that need to be done. Perhaps there's some electrification or you want to add an electric vehicle charger, but having a building owner agree to those upgrades is not always feasible. Tenants aren't really able to install DR capable equipment because they're not the stakeholders in possession of the property and the primary decision makers. Additionally, the equipment can be costly. Having a technician out, even for a simple retrofit like a smart thermostat that can respond to a demand response signal to lower that peak that David so specifically defined in terms of that, looking at that 90 amp, we need to bring that number down so that the service can accommodate, but they're not even capable of installing those technologies that can automate in that way. So again, time and cost of equipment installations, often out of reach for, in particular, in affordable housing projects, and then low awareness. There's programs out there and available both by third-party DERMS providers, so folks who manage aggregate fleets for demand response, and programs like ours, local utilities that can help them implement some of these technologies so that they can participate. And what are the benefits? How do we explain that to homeowner or tenants, non-homeowners who are managing the rest of their lives and may not have the time or attention to really focus on that. Next slide.
So we had an idea about how we might address some of these issues. Next slide. So we were sitting around and discussing, what if we could add loads, do this electrification, add loads, but figure out a way to do it without a service upgrade, which is a big issue, right? Could we turn circuits on and off to prevent overloading, so it'll limit costs to the renter for upgrades? Is there a way to do automated demand response in a deeper way, so those renters can get some advantage, and we could support the grid? And is there a way to provide backup power, so if power does go out in these apartments, that homeowner, or I'm sorry, renters and tenants can stay in their homes rather than power's out and we've got to get out? Next slide. So Ranchan from Lawrence Berkeley Lab is going to talk to us about some of the ideas that we put together that might be able to help us to attack some of these problems. Next slide.
All right, thanks, David, for setting up stage. All right, so in the next 10 minutes, I will walk through this solution, as David mentioned. Use of smart home panel and packaged plug-in batteries. So with the focus on addressing three critical challenge. So Elsie already bring up the capacity management, and David and Kimberly mentioned about load management, in particular for the demand response. The last challenge, which is grid resilience. So if you're looking at this schematic diagram, and our solution is centered on the, let me pull it up, this smart panel. So this panel can manage up to 12 circuits. And so in terms of switch over to use plug-in batteries, it only takes like 20 milliseconds. You barely notice when switch over from the grid connected to the LED mode. And it's way fast. It's faster than your lights can flicker. And for this panel, it can support up to 3 plug-and-play inverters. And for each inverter, it can support up to 5, batteries that can step up to 15, to 30 kilowatt hour per inverter. And if you add 3 inverters together, it can support up to 90 kilowatt hour in total per the panel. So 90 kilowatt hour battery typically for can support like for a typical house, it can support like at least 3 to 5 days or even longer. And the inverter is also capable of connecting the solar panel, so it can just charge the battery when there's a power outage event, or either during the grid connected, you still can leverage the solar panel to charge the battery. So it's very, it's compatible to the panels and batteries. It's, in terms of design of this module-based batteries, it's very easy to scale up. All right, let me just clean up this. Here we go. Can move to the next slide. All right, so let's dive into our first testing scenario, which is the electrical panel capacity management. So this scenario, which is to how to manage the overloading of the panel capacity. So think about you have a new electrical demand from the heat pump and electric stove. You probably can have like additional, electrical power demand from electric vehicles. So when the load approach, so this is just scenario we put together. You think about the load, which is 75 amps, and your existing panel, which is 60 amps. That's the majority of the current panel in the apartment or either in some houses. So how we deal with this challenge? So we have we install this simple switch. This most simple switch connects the circuit to the smart home panel. When the load approach to 80% of the panel capacity, which is roughly 50 amps, the simple switch will be triggered to switch off the power supply to the smart panel. So which means the panel will go to the LED mode, and all the critical load will be powered by the connected batteries. And for the rest of the load, they still can operate on the main panel, but the total load will still under 50 amps. So this is how we manage the overloading of the electrical panel. So when the load reduced to 80% of the 70 amp capacity, and the simple switch will rejoin the panel, and it just operate as normal operations. And let's go to the next slide. All right, scenario 2, which is load management and demand response in particular. So there's three type of trigger conditions. So either when the load approaches 80% of panel capacity, so we can to trigger the control sequence to manage the demand, and then below that 80%. In terms of load management, the first option we can to adjust the HVAC thermostat set point. Sometime we can raise the cooling set point about like 2 to 4 degrees, reduce the HVAC demand. And after that, we can switch off some optional plug load or reduce non-critical circuit. And for all the operations of this switch on, switch off those plug load, we just keep monitoring the load in real time. And when the either load back to under 80%, or there's no we go to the off-peak demand, or either when the DR event ends, we just resume the control sequence back to normal operation. It's so all the control logic being built into our controller to coordinate the operations among those devices. And let's move to the next slide about the grid resilience. So this is very interesting scenario we can test out. So think about this scenario when there's a power outage, and you probably can lose all the power supplies to those circuit, and you may traditionally you probably have like cloud-based load management operation, but when there's power outage, you may also lose the internet connection, and the traditional cloud-based can fail. So how to deal with this type of scenarios? So when the grid is out, when the power outage, and apparently the panel will go to the LED mode, and for the connected battery, we will support as a backup power to support only critical load. So this is how we label these loads, either critical or moderate, or either essential load, or either like non-critical load. So we just give the label of each type of load and manage these use of battery to support only critical circuit. And on top of it, we can also manage the operation of the air conditioning load. We can increase the thermostat to reduce the power demand to reduce the power use from the HVAC, which means we could extend the operation hours of the battery. And we keep monitoring the load. And at the same time, you probably still have the solar panel to charge the battery. And when the grid is back on, and we can have, resume the normal operations. So let's move to the last slide I have. This is the real scenario we already experienced in last few months. This is test unit for our in-house testing. And over the first event, which is the planned power outage on June 22nd, I get a message from PG&E. And okay, there's a power outage at 2 o'clock. Before then, I get the battery fully charged to 90%. I set the 90% as our upper limit. You can set at 100%, but it considers the battery health. I just set as 9%. This is the first event, which is planned outage from PG&E. But on July 8, that's surprising. No, it's not a planned outage event, and suddenly there are power outage in our neighborhood, and the battery just kick in. You barely notice any change of the operation, and I put the internet cable on the circuit of the panel, so which means we get internet connection, we get power supply to all the circuit on the panel. This is what we experienced in last few months. All right, next slide. I think, all right, I get back to you, Elsie.
Thank you so much, Ranjan, for going into the details of those scenarios. And now it is my pleasure to talk about where we're actually deploying this technology. And so next slide, Maddie. First of all, thank you so much to the CEC. These are grants that have been funded by the EPIC program under the CEC. And so we're very excited to dive into this. So we have 2 projects here. One of them is called Pezzer, and that is going to be up in Arcata and Willow Creek. We're going to be installing this whole power management system, the smart panels, the backup batteries in Arcata and Willow Creek. We're going to be doing 6 in Arcata and 4 at Willow Creek. 4 of the units at Arcata do have PV installed on that. And so that will be part of the resiliency testing, is to see how much further we can push it when there is a solar connection. It obviously isn't super popular for apartments, but we're hoping as we can show the resiliency scenario that maybe more apartments might be willing to add on this. Certainly in areas that are very prone to fire issues or PSPS events, that might be something that may become a reasonable request. And then in Santa Rosa, which is the project we're doing with Sonoma Clean Power in partnership with, that would be an entire property, which is deed restricted. It would be 40 units. And in the Santa Rosa project, there would not be very much electrification. There is a little bit that is kind of part of the property retrofits, but that is not the main focus there. We're focusing in Santa Rosa on demand response and how we can integrate with the program that Sonoma Clean Power already has, Grid Savvy Rewards. And so this is low-income housing where there would be a smart thermostat, there would be the smart panel and the backup battery. And so we're working on integrating them in some way. Potentially not through Uplight, which is one of the signal providers, but a couple of workarounds just to see the efficacy of connecting and being able to do some pre-cooling when there are grid events, and when there are high peak days where Sonoma Clean Power might need to load shift a little bit. And then in Arcata and Willow Creek, we're going to be doing a variety of the scenarios that Ranchan reviewed. We're going to be doing some resiliency, as I mentioned, some capacity management, and then also some load management. With Arcata and Willow Creek, it is a full electrification effort. So they will be receiving upgraded HVAC. For those that do have gas powered dryers, we will be doing an exchange for an electric dryer. There will be an induction stove. So there will be a lot more loads that will help improve the efficiency of being able to use this as a decarbonization tool, as well as for other added benefits such as the resiliency. So next slide. I touched on this a little bit, but these are some of the pilot objectives that we are hoping to prove through our testing. Right now in Arcata and Willow Creek, we're on the verge of beginning installation. And so we do hope to have this done, hopefully fully commissioned by the end of the year. Ronchin will be going up a couple of times to ensure that all of the systems are talking to each other. As you can see, there will be a variety of things. We'll have to figure out critical loads. We'll also have to coordinate with the tenants to ensure that they understand how these new systems are coming aboard and how they can get used to them. In Arcata and Willow Creek, we are developing a tenant guide that really clearly just snapshots all of the things they might quickly want to know about their new appliances. How do you turn on the new dryer? How do you turn on the new stove? What equipment can I use on the new stove? So we're really going to be focusing on tenant education because obviously there will be a lot of new products in people's homes, and them being comfortable with all of the systems being integrated will make them better testing partners so that when issues arise, we're able to tackle them collaboratively. But the pilot objectives are, one of the key ones is being able to expand panel capacity without service upgrade. Arcata and Willow Creek are going to be excellent examples of how that can be possible. And then we'll also be hoping to manage peak and time of use rates. So to minimize grid demand and utility bill, this will be some of that load shifting, a little bit of that demand response with Sonoma Clean Power. And then we're looking to extend the grid resilience. For Arcata, we're hoping, especially with those solar powered units, that we could potentially go up to 5 days on critical loads. Of course, that would be, where all of the habitants of the unit are comfortable, but maybe not all of the rooms have all of the use that they normally do. We'll be primarily focusing on refrigeration, cooking, and enough comfort where they can charge a phone, where they can stay connected, and receive information as it comes in. And then we also enhance auto DR, and that is that really peak reduction in load shifting. Next slide. And then in terms of performance targets, I think for Arcata and Willow Creek, we're really interested in being able to aid in unit decarbonization without service size upgrades. That is something that was top of mind for those units up there, as the developers, DANCO communities, was really interested in getting rid of gas appliances. They really began running up into the grid up there is also highly constrained. And so, that would be a lot of units that they would have to do a lot of service upgrades in order to decarbonize. So that was actually how it came about. They were looking for ways that they could be able to do this. We were able to also offer up the resiliency approach as an added benefit. Also manage loads and maximize benefits both to the tenants, the owners, and the grid. We're also hoping to show that by being able to use this power management system, the tenants are benefiting by ideally lower costs, or at least some cost savings, being able to stay in their home during very critical periods, being able to access medication, life-saving appliances that they may need to have access, where being able to go to a resiliency center or a community center might prove difficult. Also to the owners, in terms of the building owners, we're able to manage your cost, things like that. And then to the grid, the benefits to the grid is that ideally we're not adding excessive loads. We're able to work within what we have without adding much more demand. As Kimberly spoke, there are areas where it is certainly at capacity or over capacity. So as we allow the grid to level out there, adding some help. And then enable off-grid operations during power outages. And lastly, lower overall costs versus traditional approaches. I know David spoke to this in terms of service upgrades. Depending on how downstream you have to do additional upgrades, it can very much add up. And then next slide. So that was kind of the objectives and the goals of our demonstration, but I kind of wanted to center us a little bit and let you know where we are in terms of brass tacks. So as I mentioned, for PEZR, which will be up top above the line, we have some site prep that will be commencing very soon. We have identified our contractors both for installation and some HVAC work that will need to happen concurrently. And so we're signing contracts, permits are being submitted, and we should have that complete close to the end of the year. We are allowing a little bit of time for any permit questions, things like that. And then we'll have 12 months of testing period for PEZR. We have a technical advisory committee, which I think some folks might be here from. They are giving us really useful feedback on testing, what we should be looking out for, things that we should be interacting on the tenants on. And so we'll be providing some useful updates over that testing period, post installation, and then when we're well underway under testing. Ronshan through LBNL will be working on a measurement and verification report to help verify that data, help analyze it, and help provide some analysis. We will also have a case study after the completion of the testing period. And this will be also a knowledge transfer report. So we're really hoping to engage the industry, provide some guidance in terms of design, in terms of contracting, a variety of things. If there are folks in this room who have specific ideas or specific asks, feel free to throw it in the chat. We're really open and interested to seeing what the industry might need in terms of being able to digest this and really enact in their own project. And then for Grid Savvy, which is below, that is a little bit longer. That one actually just really got started late spring. So we are working with the developer there through Kimberly Beltran, and we're coordinating with them on installation. As I mentioned, they're doing some overall property retrofits. So we're very much working with them on how to integrate this project into that timeline. Similarly, we'll have a testing period with LBNL doing some measurement and verification and providing a report after that, a little case study and a final report. Similarly, we're hoping to provide some guidance, and so if you have any ideas, whether that's design, electrical, particular webinars that you might be interested in hearing about the testing, now is definitely the time to let us know. It can inform our approach and how the kind of data we gather and how we are able to present that to you. And next slide. So as I mentioned, PEZR's a little bit farther ahead. We've just kind of gotten started on Grid Savvy, but we have run into some challenges, of course. This is a lot of units with a lot of potential, so we're trying something new. Obtaining the site load has been a little bit everywhere. There are some folks who have that very detailed. Obviously, working with a utility with Sonoma Power was definitely a benefit and a boon that we were able to get data quickly, but that is not always the case. So working with different developers have different green button data, different site load data. It goes by slightly different names sometimes internally. So being able to get that conversation going early so that you could identify if there needs to be anything like a sharing agreement or a release from a tenant. Sometimes there's multiple utilities involved. So it can have a question that can have many parts or can be a very simple answer sometimes. Permits for batteries, as I mentioned, we're starting to undergo the permit process up in Arcata. We'll be coordinating with the city of Arcata and the county of Humboldt for Willow Creek. We've had some preliminary conversations up in Humboldt. They've been there have done a significant amount of installation, so they are somewhat knowledgeable. This is a slightly different deployment, so there are some questions, but they have had, you know, things like power walls installed and things like that. So we've already begun the conversation with them. We've already provided some materials for them to get acquainted with what we are installing. But certainly we will definitely have a lot of stories to share and lessons learned on the departments for battery that we do hope to provide as part of our guidance. Contractor education has been another one that has been a really interesting journey. Although the installation itself is relatively simple, it consists of running wiring and conduit from the smart panel location inside of the unit to usually over attic, as I think how we're going to be doing it in Arcata, and into the location where we're going to store the battery. But this is a new system, and contractors rely on consistency and knowing exactly how they're going to be doing a project. This does have a little bit of unknowns, and so that has led to a couple of bids being extremely overdone and way over budget. But we have found that there are contractors who have been willing to be educated on what we are doing. And when we break down very simply what we are doing and how it is running, a lot of them feel a lot more at ease, and they bring down sort of that unknown way down, and their costs are much more in line with what we would expect when kind of penciling this out. So that is certainly something that we will be including in some of the guidance we are able to provide as we are finishing the testing period on this. And then something we know that is coming up the pike, we haven't totally interacted with it yet, but controller interoperability. There are a lot of really cool projects out there and products out there, software. And so being able to integrate this into products like EcoFlow, I think, is going to have to be top of mind with the manufacturers. And that is something we are providing with EcoFlow. We are going to be providing a little bit of feedback of the places where we haven't been able to find products that can integrate into it. So that is some of the manufacturer contact we're going to be having as well. And then next slide, and I think I get to pass it on over to Doug and tell us what's happening next.
Okay, so we only have to do all that before the next phase. So it's obviously a really exciting time. There's a lot going on, but this is the team to do it. I mean, I'm absolutely confident in that. We've come together to form the idea. We understand the problem. We're finding our way through the first, cutting the first paths through the forest, so to speak, in being able to apply this solution. But we started this conversation with a really important number: 2.5 to 3 million. Our projects represent 52. Okay, so the difference between our project and 2.5 to 3 million is about 2.5 to 3 million. There's a lot to happen here beyond this pilot, and we take that very seriously. So let's change slides real quick. So these projects need to be the beginning of what can be a very scalable and very helpful, and I believe a very effective approach to managing the issues that we discussed today. So there's 3 things we're going to be focused on as we generate the data and the experience from these projects. 1, resources. So the work that we do to get these systems installed is going to become design guidance. The experience we all have, the good and the bad, the more challenging and the easier, will all be logged in case studies. So there will be a very clear description of how we approach this work and what others can take from it. There will be performance data. This is meant to be in a form that will be useful to electrical engineers, to designers, to owners, to architects, to other project team members, so that when people see these kind of conditions and they have these resources, they should be immediately useful and transferable to their project. There will additionally be modeling that will demonstrate how these systems have performed. That will provide some really good resources, but it needs to be augmented with real training. So we've got a number of things going on at ProspectSV that help meet this goal. From a project standpoint, on the PISA project, and of course working with Sonoma Clean Power, we have a wide network of utility, CCA, municipal utility partnerships, all of which have some connection to local contractors, building owners, other important kind of ecosystem members. Our work will link up with communications, with training programs, with other kinds of reach that each one of these partners has, so that we can get to the folks we want to and be able to offer training, offer assistance, be able to offer an explanation of what we've done. And so that we take that very, very seriously. We also, through other work that we're doing, we are establishing a training center for building decarbonization with DMG North. They're not part of this project and not on this webinar, but they're a really important partner to us. So a physical training center in San Jose, California will be an aspect of what we do to offer training and capacity building under efforts such as this. We've got additional work coming in terms of physical conferences. Do you remember getting together and hanging out and talking about things? Well, we're doing a lot of that now. We've got a new series called Mech Talks Architecture that take the technical aspects of a decarbonization set of conferences that we've been putting on, and we're adding the perspective of architects, ownerships, and other aspects of decarbonized buildings. These physical half-day conferences will be going on in major areas of the state. Our next one will be in San Francisco. We have one in the plans for Los Angeles. These are going to be very important crossroads for cross-disciplinary discussion about solutions such as the ones that we're talking about today. And then, of course, there are going to be webinars like this. Lastly, we would not be doing a great service to those 2.5 million other installs that need to happen in the world if we didn't make ourselves available to those project teams. So we are going to be offering ourselves up for feedback, advice, some degree of technical assistance and project discussion, and hopefully partnership on future efforts that complements the training and the resources that we're providing. So you can see we're going to be extremely busy, not just producing a report, but actually engaging the community at large in this industry to provide as much capacity as we possibly can. You can go to the next slide. And with that, one, I want to thank you. I don't know why my email address is highlighted different than the rest. Mine must have been a link or something, but we're grateful to everyone who participated today. We have a number of questions. I'm going to turn it back over, I think, to Ilse, and we're going to go through Q&A here.
Definitely. Yes. So now we have a time for a little Q&A discussion. I believe, and Maddie and Q, let me know if we're wrong. I think we've been answering some questions as we've gone along. But are there any that are outstanding that we should tackle first? No, it looks like we're all caught up. Perfect. Happy to open up the floor. Any live questions, please raise your hand or start speaking up.
I wanted somebody to pipe in and say it can't be done.
I'll ask a question of David. Is there also kind of room within the NEC calc when you're doing these as retrofits for metering the panels that are there, for kind of adding additional load beyond kind of the total of the connected load on a panel, or can you do that at a tenant panel level?
That is a great question, Andy. So this is like something that we've been working on with PSV and some of the manufacturers and stuff like that. So you're aware of like that what's that uh copper, Chinese Street copper, the um
Induction
induction
stuff.
cooktop with the battery.
Okay.
Yeah. So the idea is that, it plugs into a 120 volt, but you can get, obviously you can't run like 4 burners on an induction cooktop off of 120. So it's got a battery built into it that augments the 120, right? So one of the things that we're talking about and looking at is why can't you do that at the apartment level, right? Same concept, except instead of at the stove level, you do the whole apartment that way. The technology's there, but uh, we haven't seen it done in a way that it like lends itself to what Kimberly's trying to do, which is uh, smaller apartments with 60 amp panels. And
What I'm getting
so
at though is like not technology on the equipment connected, but just the fact that when you do a retrofit on something, when you come back to an existing project, doesn't NEC let you meter the panel?
NEC does let you meter the panel, and you can kind of put a safety factor on that and take whatever's left over and use that. And
Okay.
a lot of times, well,
Because
that's
maybe
what
then
we're
you get more
always looking
connected,
at.
more than 60 amps connected to a 60 amp panel because it really doesn't ever use it.
Yeah, I mean, yes, it's what it actually uses. So one of the tricks that, we used to do when you and I were at Integral was, um, you measure it and you find out that it's less than the calculated design load. And then you use that spare capacity. And then sometimes I've seen it done where you install something and then measure it again and you find out that it's below again, and kind of do this iterative process where you keep adding electrical load, and use the NEC to allow you to keep connecting stuff because the calculations are very conservative. So
Yeah.
that is
I
a
suppose
strategy.
the challenge there is just consistency and having confidence that you'll be able to apply something to a certain set of apartment
Yeah.
units.
And
Yeah.
and there's a timing issue too, right? Because
Right. You got
when
to
you're
do 60
connecting a bunch
days
of
if you
stuff,
don't
you
have
can
it.
only
Right.
connect so much before you go over that 60 amps, right?
Yeah.
With a lot of this equipment. So sometimes you can only add one or two things.
Yeah.
And Sean can talk about, there is a study done up in Sacramento, I think, of like 60 amp services and all electric buildings in Sacramento, which is a very, hot climate.
Yeah.
And the vast majority of them actually were using less than 60 amps, like when you looked at the annual peak demand.
We do
So
have other questions.
Okay. Go
You
ahead.
wanna
Thanks.
Give some time. You'll say, are you still MC?
Yes.
Okay.
Yes. Tom White with one question here. Many multifamily communities have central DHW. Would this study include those types of buildings?
Absolutely. Tom, maybe you can articulate your thoughts about domestic hot water and this project that has you thinking.
Oh, hi, Doug. Thanks for taking my question. It has to do mostly with the large loads, electrical loads for heat pump water heaters that are serving, 50 units, how, you can incorporate that into the study, and if there's a specific plan for those types of projects.
Oh, for centralized systems.
Centralized systems, yes, yes.
Yeah, this particular application is obviously apartment unit level, but there are similar solutions that are looking at building level. We see this as an area that still needs a lot of work. So, I mean, noted with regard to centralized systems, that's something that would have to be handled at the building level. but there's similar approaches happening at building level storage that we could employ.
Thank
Is
you.
Sean
It's
still
on our
on?
radar screen.
Yeah, Sean's still on. So Sean, we're working on that project together up in Sacramento that's got a central heat pump boiler for,
Yeah.
multifamily.
And that one, the CO2 boiler went in, and I think it has a COP that's in between 2.5 and 3. It's a CO2 heat pump, solid all the way through the winter. When you'd get COPs, that would be in the ones, like 1.2, 1.7 for some of the other refrigerants that you'd be using. So strong wintertime heating performance. And we didn't have to upsize the service of that building. That was neat. That was a hotel with the big old gas boilers, and there was no significant challenges to electrifying it, no increased service, etc. It seemed like what I've seen is that there's been probably 75 apartment complexes that have gone through electrification with AEA a year for the last 7 or 8 years now. And some of my former interns are now staff at AEA, so I get to hear about it. And they have figured out, they struggled in 2016 through 2019 to figure out how to do central heat pump boilers without increasing services. And they haven't had a problem in the last 5 years with all the different strategies they've figured out with storage and the efficiencies of the system, and maybe a little bit of rewiring because of removal of incandescent lights and field monitoring. And so I think that challenge is accomplished, like through efficiency right now and other storage strategies. Does that address the question?
Thank you, Sean.
Yeah.
Yeah, I think so. Okay, and then I think we had one question. Doug, maybe you could speak to this. Kruti was wondering if we could talk more about the System Training Center partnership. I already provided a link, but she's curious to learn more about the purpose of the training center, who the audience is, and what exactly you'll be providing.
Absolutely. So, Kruti, I would have you speak with your colleagues at CEC, Jason Tancher and Christian. Why am I forgetting his last name? Oh my God. Okay, my staff is not helping me. Christian at CEC, we have 2 projects going on in the advanced heat pump space where DMG North and Flow Environmental Systems are involved. And as part of that project, we have established through matching spend by DMG a physical training center in San Jose. The vision for that training center is, of course, to provide important training on low GWP heat pumps and advanced heat pump applications for decarbonization. But the larger vision with DMG is that we make that physical space a place for other training across decarbonization systems. So that can and will include approaches such as power management and multifamily. So there's a grand opening of this space in just a couple of weeks. It's October 14th in San Jose. And we'll be, making more information available about the content from that space and additional events that occur around that. And it's Christian Fredericks. Thank you so much, Carolyn.
Okay, and I know we're a little over time, so if there's a final question, super happy to answer. Okay, I know some people have dropped off, so I think, and here are our emails as well. So if there is any question that comes up after you've had some time to sit with us, please feel free to reach out. We'd be happy to engage and answer any question you might have. We will be sending out the slides as well as access to some of the recording, as well as links to the project pages as well. Of course, you're welcome to sign up for Pathways. We'd love to keep you abreast of how these projects are developing, especially once we get to sharing some results and some data. So please definitely keep in touch. And thank you so much for your time and attention today. Really appreciate you all.
Thanks all.
Thank you.
Thanks.
Thank you.
Thank you.
Thanks so much, all. Thanks,
Thanks.
CEC, for the investment. Thanks, guys.